Okay, yeah. Okay, so hello everybody. It's not okay? It's okay? C'est bon ou pas? C'est bon? Okay, so thank you for attending this session. So during the next 20 minutes, we are going to talk about the digital twin for infrastructure. With a specific focus on the following question. Why open exchange schemes are a must-have for ensuring the success of digital twin for public infrastructure decision makers. So Nicolas will illustrate with a minimum value product the vision that we have for an open digital twin. So before we start, a quick introduction. So I'm Lionel Fabre, Head of Digital Deployment at Aegis.
Hello everyone. My name is Nicolas Ferrara, and I'm the Head of Digital Services and Tool Solutions for the rail unit in Aegis. So now we're going to start with a short presentation of what is a digital twin.
Exactly. So, what is a digital twin? It's not so easy to answer to this question. So at Aegis, we've been working on this topic for a few years now, and we have published a white book available on our website. And for this question, we have organized the digital twin in 5+1 points. So the five first points are I would say the most common points for digital twin. That means this is a virtual replica of an asset as it operates. A decision support tool for all the phase of the life cycle of the project. So for this it means the continuity of the information. A real-time asset management tool. So this one is the capability to monitor the project. The basic for the simulation is also a part of the digital twin. We have the collaborative platform, donc allowing interconnection stakeholders. So this one is how to federate the models and how to work together on the digital twin. And the last one is an Aegis specificity. So this is a platform for the development of sustainable services. So Nicolas is going to explain what is it exactly for us.
Well, actually, as Lionel said just before, a digital twin is not only a software, but it can be seen as a platform. As you can see in this diagram, in our vision, we think that the digital twin is a kind of hub on which you can plug whatever you want. I mean, any application, any business tool linked, for instance, to the planning, to the construction, the safety, or whatever. And the hub, so the digital twin, aims to bring the most reliable data to the users that you can see on the top of the diagram. So that's quite obvious for us, and it's something that we want to focus on. But that's not the only thing. In the case of the public infrastructures, we think that there are many other challenges to face for a digital twin model. Actually, the public equipment needs some cares, let's say. Public decision makers are obliged, first of all, to bring some transparency. They have to onboard every kind of stakeholders. On the picture, for instance, you can see some firemen. So they have to bring a digital twin which is easy to use and easy to access. Another thing is that they have to start with something from the beginning, even rough, let's say. And so, for that reason, the digital twins should be built step by step, brick after brick, and it's not it cannot be seen as a monolithical product. And the last, that's the public decision makers sometimes need to let's say, to work with newcomers or small little startups, for instance. So they have to choose their software vendors, not only the famous big ones, let's say.
So how we can implement a digital twin? So for us, for Aegis, we are convinced that we need and we must to follow the 4 points to ensure the good, I would say, that the digital twin is online with our strategy. That means we need, the digital twin has to be compliant with international standards. So we need really to use open formats, so IFC, for instance, or CTGML or PLCS. So because if you want to be free, I would say, regarding the software editor, we need to be able to have this kind of format. We need to use a workflow compliant with the BIM ISO 19650 standard and metadata exchange tools like EFC formats. For doing this, we need also to have a constant access to the web services, because with web services we are able to federate and to address the same platform. And the last one is the real-time integration of data. This is to allow the optimization of simulation in the model.
So the digital twin aims to be used by any kind of people, as we said before, and it will be used for the operation and maintenance phases, but also for the construction. As you can see on these small pictures, well, I don't want to go to the detail, but as you can see with the digital twin, the people need less time to prepare their interventions, and they have also a way to train themselves. They can manage in a better way the assets, and for instance, it's a little bit provocative, but they can say, okay, what I have inside my pipes, what can I resell, or maybe rent, okay, to another operator. And last but not the least, thanks to the digital twin, you can also have a view on the footprint, on the carbon footprints, and maybe have some KPIs to manage it in a proper way. So some concrete examples.
Yeah, absolutely. So here we have, you have some examples that were implemented in Aegis. I'm not going to go through all the examples. It is just to illustrate what has been done. Finally, it is not just for building, but it is also for infrastructure. So, for example, we have a digital twin for a building, for monitoring a building for a French bank. We also have a digital twin for the simulation in the Tourmain Parnasse project. And we also have another digital twin, I would say, for infrastructure project. This is the project in Marseille, a tramway in Marseille, where we implemented a platform around IFC, BCF, for being able to have one platform for all the, say, the actors of the project. So another example, so this is augmented reality. That is something that were implemented in a project, in a highway project. So the objective of this is to be able to, would say, to control the difference between the as-built and as design. In this example, we were able to check and to see the difference between the pile of the bridge. So it was quite interesting. And two other different example. This is interesting for this because it illustrates the role of the BIM GIS in the process of the production. So for this example, the first one is for a tunnel. So it was for the supervision and the maintenance. This is based on a Web.js application, and the other one is for a Viaduct. So this one is interesting because it's based on IFC file, published, connected to the Web.js platform, and the objective was for the pathology reports and monitor the breach.
So another works that we made during the last 3 years is a product whose name InMassist, and which is dedicated to the interfaces management. So with InMassist, for instance, any project engineer can manage in a better way thousands of interfaces, and you can see inside the BIM models which object is linked to which interface. So it's an interesting job that we did with Eurostep, which is the software vendor of share space, and we also collaborated with Katenda. So now in 2021. Aegis decided to start a new project, still based on open formats and open protocols, but this time connecting not only BIM and PLM systems, but also IoT, CMMS, data collection, and so on. So the goal was to see how to have a kind of light digital twin made for the operational maintenance. So when I say light, I just want to say without any big developments, okay? And after 6 months, well, I'm pretty satisfied because I think that we managed to get some minimum viable products that we are about to show you now in a couple of minutes. So before doing the demo, it's just some, let's say, key figures and ideas about the project. So, as you can see, there were a lot of different actors into this project. There were some software vendors dedicated for each part of the digital twin. So every company came with his lighthouse product, okay? So Katenda for the BIM, UBPace for the data collection, CAR for the CMMS, us, I mean Aegis for the asset management dashboard, Eurostep for the PLM solution, and Veslo for the IoT monitoring. And so all these people work together to tell a story that some of our experts tried, let's say, to draw. And we, at the end, we had some very clear use case to face and to answer. For instance, I am Patrizia, I am Manuel, because we imagine some people. I want to get more easily some documentation for, I don't know, accessing this technical part and blah, 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 blah. So this is the big story that we started to tell, and that we rework again until the end. And thanks to that, we will stick to the story, okay? So now I need Gabriel to start the demo. Stop making long speeches. So that's it. Maybe can we switch again to the slides, please? Okay. So what we did, as you saw, it was let's say the proof that we can connect existing bricks as a part of the IT system of an authority or at let's say transport operator and so on. So it was a very exciting project, and I would like to thank you again, all the partners of this project and my colleagues as well. So part of them are in this room. Obviously, we are ready to discuss, but after that conference. Lionel, you want to say 2 words to finish?
Maybe a short conclusion. So we can say now that the digital twin is no longer, I would say, a myth for AGs. We are now able to support our clients in their project. So as you can see, the height seems to be huge, but do not hesitate. There is no risk. The risks are under control. Thank you for your attention.
Thank you.
Thank you very much. Oh, sorry. Thank you very much for the presentation. So, and to be in time. So we have a short time for questions in the rooms. And if Frederic hear me, because he's not in the room, but in the map or somewhere.
Yes.
Okay, Frederic is here.
I can hear you, and there is no question right now in the chat.
Okay, you have one. So you can read the questions for us, and people from the room prepare some questions if you have. We here for you.
No, there is no questions.
No questions. Sorry, I apologize. So, if someone have questions for the presentation. Maybe to the movie you show.
We don't bite.
Sorry, the questions. Okay. So. No. Please.
Sorry again.
Yeah. How do you update the model? So I saw in your scenario. Okay, there's a default. Okay, the data goes all over the place. It is maintained, and when it is maintained, how do you do that? How do you recreate the model so the twin is still a twin, not just a duplicate of the past?
Yeah, in this first architecture, well, the model is not updated itself, because what we have to modify is it's the data, and the data is managed into the PLM platform. Okay, so for instance, the serial number of the such equipment is changed. This is managed into the PLM platform, not the model itself. But there is a link between the model and the data, basically.
Okay, but when reality changes and the model is not updated, at some point after 1, 2, 3 iterations, you will have a gap between reality and your models, and how do you
you're right.
manage that?
Sometimes, because on the field, a lot of things evolve. So sometimes you will have to manage to modify the model. So it has to be done by somebody skilled in that. So well, but it's not a big deal.
Just to finish the full loop.
Yeah.
That's the last.
Yeah.
Thing.
For the CMOS, also edges from the asset management dashboard, we are set for the PLM solution, and this way for the IoT monitoring. And so all these people work together to tell a story that some of our experts tried to and we, at the end, we had some very clear use case to face and to answer. For instance,
Just a comment to respond to Philippe. The PLM model is able to support the whole life cycle of the. Très près, okay. Yes, the model of the PLM is based on standard first and is made to support the whole life cycle of the products. So any change, any properties that is changed, any relationship, any adding of a new components can be updated in the model. Even the geometry could be providing someone, of course, is able to collect this data and forward it to the system. But all the arrows that we saw in the last pictures describe this relationship and data exchanges between all the software that are being used.
Any comments, questions? So do you use this method for the tramway of project of Marseille?
No. In the frame of that project in Marseille, it was only a matter of BIM, okay,
Right.
and somehow some kind of GIS as well. But what we did on that project is that we decided to develop some BIM models along the whole line, let's say the whole perimeter of the project, so 6 kilometers. And everything was made in BIM. So it was one of the first time that we did that 2 years ago. So kind of prehistory for BIM. And every stakeholders used it to make decisions, to have some design reviews, and well, to collaborate in a better way.
Okay, thank you. No comments? No questions? Frédéric, questions from the numeric world? On the other part?
The digital world.
No. Il est plus là. I'm not sure he hear from you. No? So, I don't know exactly what time is it. So it's okay. So I suggest to stop there, to have only 1-2 minutes to change and to begin the new one.
Thank you.
Thank you very much for your presentation. Thanks a lot. And now with the ready, so is the next presentators ready to, is there? I think it's, Jacquart Serini. Jacquart. On n'a pas de retour sur le numérique. Il est là? Okay. So he is ready to present? So,
yes.
And okay, thank you. We hear from you. That's good. So the room is here, and I think in 1 or 2 minutes, okay, no problem, 2 minutes, because we need to have some delay to project your screen on our screen to the room. So at the moment we have the screen of the rooms. As you can see, you have about 20-30 people here. So
yes, I can see. That's very nice.
You can see the room from Finland. It's okay?
Yes, I can see. Yes.
Okay, but we can't see you. At this moment, you are not on the screen. Not at all. Liverpool. Oh, what? So Jacquart is not still on the screen. It's okay for you? So, okay.
Now I can see
Jacquart, we can see you. The room will be to you in when you're ready, so you can begin when you
Yeah.
want. It's okay for
I
you?
am ready.
Okay.
Can you see my slides also?
You can go for 20, 22 minutes, and it's okay. Let's
Yeah.
go.
Can you see the slides also?
Let's go. It's to you.
So the slides are visible. Okay.
No slides.
I am sharing my screen.
Only you. With the sunshine or your light, I don't know.
Do I need to see?
Probably the light.
I will share my screen again.
He
Can I see?
needs to share his screen with you.
Yes, I am sharing it.
There is a delay between you do the things in your computer, and it's maybe 20 seconds, half minutes. It's right for you?
I have the screen sharing on.
No.
I have it here. I have it here on.
No.
Okay. Okay. What should I do then? What should I do then?
Okay. So.
Okay, now I can see.
Okay,
now I
it's
can see.
okay. You can begin your presentation.
Okay. Okay. Okay, thank you, everybody. Okay, thank you, everybody. My presentation is about modeling. My name is Jarkko Sireeni. I'm based in Finland. I'm Helsinki, Finland. I am currently the chair of the City Modeling Group in Finland, where we think in the city perspective. I'm also a CEO founder of XD Visual company developing, which is a company developing open twin platform for information management.
Jacquart.
So a bit motivation. Why modeling information modeling is coming from United Nations.
Jacquart, you can stop.
They have estimated
You need to stop.
2050, almost two-thirds of people.
I think you have a problem with your computer, the micro,
That means that most of construction will happen in city environment, and that sets kind of new requirements for project
Tu peux mettre l'image
management.
pour que je lui dise d'arrêter?
And what it actually means is that the projects are in existing city environments, so we need to manage the whole city environments
you need to
with
stop.
all the different disciplines, not only being for buildings, being for infra, but everything together in all different scales, in project level, in area level, in city level, or even in multi-city level. And also in all life cycle phases. So we might have a building project just starting construction and infrastructure design and so on. And everything has to be managed at the same time. So that is the kind of the idea of information modeling. We manage information in the cities in a holistic way. So urban information modeling, a bit kind of definition about this new term. Traditional BIM, what mostly everybody is talking today is in project level. So the goal is to make optimal project implementation using information modeling. And quite much focusing on the design and construction phases. But the cities, they are looking for the whole life cycle. They have projects, they have planning, in design, construction, in construction, in the same time. So you need to be able to manage. So you need to be able to manage this in holistic way. And this is related to city development. This is related to city development and area development. And if we think about even larger scope for urban information modeling, smart cities and digital you now.
No. Sorry, Jacquart.
Yeah, this platform is maybe a new one, so. But if I now turn off my speaker and continue, just let me know if it's not okay.
Ça peut pas venir de nos micros.
So now my speaker is off now. I hope everything is good. So I think we already discussed about this concept, so maybe I can continue from here. So example of what urban information modeling is, or urban information model. This is an example railroad project. It spans about 95 kilometers in Finland, and it's going through multiple cities, and it has a lot of different kind of areas that it will pass. And the typical urban information model is combination of map and terrain data when you start the project, a lot of different kind of GIS data like the nature, cultural heritage, pollution, noise, traffic, land use. You maybe have some models if you are building this railroad in the city environment. And also you do a lot of site surveys when you start design projects. You survey the site, geotech underground, also terrain model surveys and so on. Then you start planning your design, and then we start talking about BIM models. So you have a road and rail signs here, BIM model, format, and of course related you have bridges, you have tunnels, and all other different things as a BIM models, which are combined with the surrounding map, terrain, and GIS information. At the same time, because typical infrastructure project, it will generate a lot of new land use. And that is the purpose when you're building a new railroad, for example. Each station is surrounded by a new upcoming land use. So the cities, local cities, they are making city planning. And that relates then goes into new buildings, new streets, new pipe networks, new street and landscaping, and that, all that kind of things. So the cities and the project itself, they need to collaborate together and communicate together and coordinate together. So basically, urban information modeling is combining all of this together. Different data in urban information models. We have the traditional BIM objects, like for buildings, wall or window, or for infrastructure, you can have a pipe, manhole, terrain surface, and so on. Then you have a project level where you have these constructible elements like buildings, roads, bridges, tunnels. And this is the typical kind of BIM project level. But when you work in the cities, you also have area planning, you have traffic planning, and also in area planning phase, you combine all the infrastructure and buildings together. And all of this can be in different life cycle phases. You are not going to build this kind of area in a couple of years. It will take 30 to 40 years to build. So there is always a life cycle perspective. And if we go into city level, the city has a lot of these different areas, so even one city can have hundreds of different projects. And all of these combined together can be a kind of a citywide information model, combining the existing city and the future city. There is also new layers, data layers like security and living and business, health, public transport, air quality, and that kind of things. But sometimes the projects, they go over the city limits, and then we're talking about regional urban information models. You combine 2 or 3 cities together into one model. So you combine city models, you combine all the regional information like water, waste, environment, energy, climate, and so on. And finally national level, or even multinational level, or even in European Union level, you have a lot of different data. And all of this data can be combined together with this UIM concept, so that the project can use information from area, city, region, national level. And the data types typically are BIM models, it has GIS information, it has city model information, it can have survey data, and especially maintenance, it can have IoT data and different kind of registers and databases and so on. Couple of examples of different kind of data. This is a global level data. This is OpenStreetMap data. So we have a terrain model, we have all the buildings, we have satellite images, we have map data. So this kind of data can be or covers actually globally. So you can get this kind of data anywhere in the world. So if you have a project in any city, you can start with this kind of data. National level, this is from Finland, example, Finnish National Mapping Agency. So Finland is laser scanning the whole Finland. We have point clouds with a half point per square meter as public data and 5 points per square meter as a request data, separately requested data. And also they start producing a 3D building registry in CityGML format, so we will soon have all the buildings in Finland in 3D models. And this is quite useful data also to start with the project where you don't have accurate site surveys. You can start using with this data. In regional level, here is an example of combination of Helsinki city model and Espoo city model. And what is interesting here is that this is 2 different city models in 2 different coordinate systems. So you need to be able to combine multiple coordinate systems together. And then we have traffic information about the traffic volumes, traffic network, public transportation, city bikes, and that kind of things. And this kind of information model is needed for projects like a highway or tram network or something like that covers multiple cities at the same time. Here is an example of a city model. This is a Helsinki city model. So Helsinki has a very accurate city model in 2 different formats, CityGML and also this kind of photogrammetry model. And all of this can be used as a data for the project. And you can bring your BIM models into this city model. Some example GIS data. Here is some city plan regulation maps on top of this is air quality data. This is nature protection areas, different kind of vegetation protection, bird areas, and that kind of thing. So all of these can be imported together with your model. This is an example of traffic data, bus tram networks and city bike information and so on. And this is traffic pollution information. So there you can see in red color the areas that you have a lot of traffic pollution in Helsinki. And this is traffic noise data. And this is very good information for area planning, how to improve the city in the future. So basically these projects, they are in multiple scales. can be national projects like these long railroad project or long highway projects, transportation projects, energy projects. You can have regional projects that cover multiple cities. You can have city projects inside the cities, and then you can have individual projects in building level or street level. All of this can be managed together with different coordinate systems, elevation systems, and different data formats, being GIS and so on. For example, in heavy infrastructure, I call it heavy infrastructure, that for example, this railroad project, you combine BIM and GIS together, so you can, for example, check how the design fits into the area plan regulation. There's a certain area that you need to fit the railroad. So you can check that, for example. And of course, you will have different models. You have railroad corridor models, bridge models, tunnels, and all of this together. And always in this project, the collaboration is important. Internal collaboration between the designers and external collaboration to decision makers, to local people, and to city council and all the stakeholders in the project. This is an example video of this urban information model of this project. So here you can see the city model and a lot of GIS maps combined with the actual BIM model of the road. There you can say bridges, tunnels, and all of these are in BIM model format. Here you can see the area plan and the 3D model of the BIM model of this design. It doesn't actually fit into the area plan regulations, so there is a conflict right away. In city perspective, this example, for example, Helsinki City has a lot of new projects like here there was a presentation about this Kruunusilla project. There will be a new residential areas, new city development, a new tram connection, and that affects the whole city. So this urban information modeling takes all of this together and manages all the information together. And then you can coordinate inside the project, but you can also coordinate between the projects, and you can share information between the projects. So you can use same terrain model or same data in multiple projects, and then you can also simulate the project. And this is where time perspective comes very important, that you can simulate the project with 4D, so that you can do construction phasing, area planning phasing, and even accurate 4D scheduling for the project. So you can make sure you can virtually simulate the project before you actually construct, so you can eliminate all the possible errors in the project. This is an example of how this urban information model, when you are walking the city, urban information is actually already existing around you, but you don't have ways to see that information. For example, mobile devices and augmented reality, you can bring that information visible. And that is kind of how you use urban information model on the construction site, or with public collaboration, that you can access that information with automatic positioning and automatic reality applications. Then you can see information. This is an example of new high-rise buildings in Helsinki, but any kind of information, kind of project that you can access this way on site. Area planning is one small part of this information modeling, important part, because that is where you make biggest decisions for this area. For example, Kalasatan area plan here, you can sketch different alternatives, you can analyze the new design, you can combine traffic planning and also combine the 4D time, so you can simulate this area, which is actually going to be taking something like 30 years before this is constructed completely. And it's important also collaboration when you present this to the decision makers. You can show what this is looking like 1 year, 5 years, 20 years. So you are not showing only the static image of final result. So here is an example of how the 4D simulation works, or how the area will be constructed. Area development is more advanced than area planning. Area development takes the whole life cycle. It takes all the disciplines together. This is from Tampere. So there is both area planning happening, in detailed architecture planning happening. There are multiple projects. There will be an extension of the tram line here, and also this area development project, and maybe also construction, and everything happening in the same time. So with this urban information model, you can manage the whole life cycle in different phases, different projects, different disciplines, and collaborate and coordinate everything together so that you get optimal implementation of this new area, maybe for the next 20 years. Here is an example how the city model and IFC models work together. So you can just drop IFC model of the building into the city model, and this is much more visual and much more informative when you see the actual project surroundings where this building will be constructed. And same applies for infrastructure BIM models. So you have a city model, and then you can put the street design BIM models and network BIM models and combine them automatically, natively, without any conversion. So all of these go. There are many formats. The city can be in city GML. The infrastructure BIM is in land XML. The buildings are in IFC. So it's kind of a hybrid model of all of these different standards. And it's not reasonable to think converting these different models together. And even if you go to construction site, and especially if you have a construction site in the city, you have very limited space. So you need to be very careful how you placing your storages, your construction workers, how they are going to park their cars, what are the construction areas. You have always traffic going on in this area at the same time, and it's very difficult to manage the construction site. And with this digital information model, urban information model, you can combine the design models with the city model. So you are not limited only to the design models when you are looking at the construction site. You can use different kinds of spaces around the construction site, for example, storages or parking and so on. And then you can do easily site planning in 4 dimensions, that temporary elements, where how is the site evolving during the project. You can also bring here the survey data, so you can make, for example, drone photogrammetry every week, or you can measure point clouds, and then you can compare the point clouds with the BIM models. Did you actually construct correctly? And of course, add the time perspective here. For example, here is an example of very good point cloud. The point cloud is only in this limited area, but you have a city model combined with the point cloud, so you can have much more better perspective about the project area. And the point cloud can be very, very accurate. This is something like 300 million points in this point cloud. So if you zoom very close, you can see very small details, and you can do very accurate measurement from this point cloud. And this kind of point clouds can be updated every week for the construction site. And of course, if you have BIM models, they would be combined also here with the point clouds. This is an example of a bridge renovation project. So they are going to repair this bridge, and the traffic flow is very important, and the space allowed for fixing the bridge is very important. So with this 4D model, you can simulate the different construction phases, and also these blue and green areas, they are the areas where the traffic is flowing. So you can actually manage the space with the time very, very well with the 4D simulation. But how to get this working so that everything works together? You see good examples. So technically this is working, but standardization is the key, so that we can utilize this idea in all of the projects. This is what we have been thinking in Building Smart Finland. We have these 3 main industry groups: building, infrastructure, and city. And all of these groups working together to make guidelines, coding, naming and coding systems, and format standardization, so that we can exchange data between these and everything work together. We are not quite there yet. There is a lot of different formats going on and used in the projects, and also different kind of data. For example, the initial data for infrastructure project, you can see the yellow ones are BIM, but the green ones are GIS. So you cannot actually have a BIM model of infrastructure project only with the BIM formats. So you need to have BIM and GIS together. And this is now our goal in Building Smart Finland, to unify this information management in both building, city, and infra, so that we are looking at the constructed environment as one information model. And we have a new program starting, development program, 4 years into the future. And we started developing this program based on the processes. So the processes are like use cases, how you are using the information. These are kind of business processes. So these processes, they create value for the industry. And on the other side, then we have the standardization. And the standardization, we now start thinking that we should not have separate guidelines for city infrastructure and buildings. We want to combine this as one modular standardization process, so that we have one standardization for the whole urban environment. And it's kind of modular standardization. And we also, when we were preparing this project, that there is always some obstacles in between the process and standardization. And we found out that, for example, agreements, they are big stopper. Why BIM is not used in projects? So even if we have very good standardization and guidelines, the customers or the owners will order drawings. So we start this new campaign, drawings of campaign, that how to make the agreements and all these so that they support actually BIM workflows. Another big thing is accessibility. So this standardization is kind of a special knowledge for special people. We want to make it accessible for everyone in the industry. Every foreman or everybody working in the project, they need to have easy access to this standardization, guidelines and coding and that kind of things. So developing the knowledge is key element here. So we're planning to put all this information into the national university and all the school training programs and professional training programs, and we are going to make common learning materials for this, so that we get this everything working together. And the key here is also to think this as a big picture. We cannot take only one piece, like let's say quantity takeoff. That's very important for everybody, especially for construction. You cannot make quantity takeoff without design, and design cannot be without good initial data model. And the design and designing will not be BIM-based designing if the ordering or agreements are not based on BIM agreements. So all of these has to be fixed so that we get into these benefits, like better CO2 analysis or digital delivery or optimal usage and using BIM in maintenance and so on. So all these value chains have to be solved. And this is the key goal what we have. And you can also look at the life cycle perspective, that you have this certain kind of common task, collaboration, coordination, communication for the whole life cycle. Then you have different use cases in different phases of the design or phases of the project. And you have different kind of models in different phases of a project. You have city planning models, design models, construction models, as-built models, maintenance models. And all this life cycle has to be fixed so that the data will flow and the data can be used. And the key element here is that the more you go on the right in the life cycle, the less you can influence the end result. And the main goal to influence in main result is probably to influence the cost or influence the CO2 that will accumulate when the project go here. So my key point in this slide is that if you invest, for example, 2 times more money in the planning and design, you can reduce the construction cost maybe 10 or 20%. And that reduction in cost can be easily 10 times more than the double investment in planning and design. So the benefits we get from urban information modeling is that the information will flow from phases to another phases, between disciplines, between projects much better. The productivity and quality will increase when we have good standardized ways of working. We have good guidelines, everybody working in the same way, and we can do also automation when the data is machine readable. Leading with information, that is very important for the life cycle management. So we need to make sure that the data is always up to date and the data is also reliable data. Sustainability, that's very important. So we need to integrate the sustainability as a sixth or seventh dimension into these models so that the sustainability information is from the planning to design, construction and maintenance. So we don't lose that information. And also increased understanding. When we have all the information together, it's much easier and faster to understand the situation, especially with collaboration communication. If you communicate with information that is based on facts, you get more trust and you get more acceptance in the project. And of course, with different kind of analytics, simulation and optimization tools, you can reduce the risk, time and cost in the projects. So the summary, urban information modeling as information point of view, it's combination of BIM, GIS, city models, survey data, 4D schedule, 5D cost and resource information, 6D maintenance information, 7D sustainability information and so on. And this is a group of people. I need to thank these organizations. This is a city modeling group that where we have been thinking in Smart Finland about this, just to advertise good solutions from Finland. We have very good technology solutions in Finland, very good knowledge, and the cities in Finland are also very active in this development. So I think we will get very good concept in the future for this. More information can be found in Building Smart Finland webpage, and also if you are interested to see one solution, there are other solutions about this that can do all of this in what I presented here. You can go to this XD-Twin.io, but there are also these other solutions that were visible in the previous slides. So please check all the Finnish knowledge and Finnish companies working on this area. I hope I didn't go too much over time. We have time for questions.
Okay, thank you, Jacquart. You hear me? Do you hear me?
Yes, now I can hear you.
Okay, thank you. So thank you for your presentation. We apologize for the beginning because we had some problems in the rooms. So at the third part of your presentation, things will be okay here, and we hear quite better than at the beginning. So we haven't find what was the problem. So we hope not to have again. So thank you, Frederick. Maybe you have some questions in Brada, and you can have the hand and ask for question.
No questions right now on the virtual side.
It's okay. If there is some comments, questions in the room for Jacquart? No? Everything is clear?
Wonderful.
So it's yes, wonderful presentation. So, do you think this methodology is the future, or there is a hand pointer to do that? So, what is your opinion?
The technology is always here, already here. So, for example, XD-Twin solution can do everything what I presented here. I think the key thing is that this is not standardized. So we don't have common rules and common standardization for this. So we need to work on the standardization, and then this can be applied in wider areas. So I think that is the key element, and that is what Building Smart Finland is working now, starting to work in the Kira Iradiki-based program. So.
Okay, so standardization is a key point to progress and
Yes.
to have the same way for the future. So, no comments on standardization. So, in France, we say city modeling, SIM, information modeling, city information modeling. So, urban information modeling, it's the same for you, or it's something better?
It can be even larger because this might not be always in the cities. It can be in small municipalities, in countryside, in the not constructed environment also. But in most cases, this is in cities, and city information modeling or city modeling is mostly focusing on modeling the city as existing element. But I think urban information modeling will take the existing city models and then the design BIM models and GIS together. So I don't think the SIM includes these elements.
Okay.
SIM, also the SIM in USA, they call SIM as InfraBIM, civil information model. So it's very easy to mix up with this.
So we need also to standardize the vocabulary and the worldwide to say the same things. Okay, so if no questions, no question on Brella, Frederick? No question from you?
No question.
No. Okay. So, Jacquart. Okay. Say.
Sorry. Maybe I have a question. On the standardization side, what is exactly your plan to have a specific standardization group in Finland and push it at international level? How do you see the future on it?
Yes, the standardization, Building Smart Finland is a chapter now in Building Smart International, and of course, the standardization, we hope that we can influence the international standardization so that international standardization includes all the ideas we get in Finland, so that will be like a global standard. So we are not trying to make any standard for Finland. We are trying to make a global standard that can be applied to Finland. So that is kind of the correct way. And I think for standardization, because we are now talking about GIS also, that we cannot only focus on building smart, we also need to work with the OGC so that we also standardize. For example, the city model standards, they are OGC standards. So it's an international collaboration, and the problem is international, and the use cases are same everywhere, and this can be applied as an international standard.
Thank you. Yeah, that's great to have input from Finland to launch this work, and then to have it internationally. I fully agree with you. Thanks a lot.
Okay, thank you, Jacquart. Thank you for these presentations. Okay. Apologize again for the problems. And so we will stop now. So I remember the room that the next presentation, the guys who want to present is not there, so it will not be the presentation now. We will have the next one, but due to respect the timetable for the people who are in the numerical way, we will wait short minutes to start, a little bit delay, okay? And hope you will come back in 10 minutes for the next one. And during this time, we try to connect Valtteri, and hope everything will be okay for the next presentation. So thank you very much. Bon, il est connecté. Ok. Ah bah t'as vu, c'est n'importe quoi. Ça met ces trucs. Ouais. Ah oui, c'est n'importe quoi.
C'est des mots qui se rajoutent. Ouais.
Okay. Ouais. Sinon, la solution n'aurait pas été prise. Je suis d'accord.
Et le bruit et le son, comment ça se fait que ça merdait le son du oui?
Eh bien, a priori, moi, au début, j'avais pas son image. Du coup, je l'avais ouvert dans une nouvelle.
Oui, Valtteri, you hear me?
Yep, I do. Can you hear me?
Okay, thank you. We have a little delay because the presentation, the people are not there and they can't present in remote. So we wait
Yep.
a little time for your presentation to be
Sure.
to be in time or for the people who are in a numerical view. Okay.
Yep, that's okay.
Could you please show your share your screen with the regime?
I thought I was already sharing my screen, but I can do that again. Just a moment.
No. Wait. Okay, it's okay. We have the screen now. We have you also on the screen. I think you have the same things.
Yeah, I think I'm currently sharing my PowerPoint slide.
Okay, everything looks working well. So we have
Yeah,
no
from my side, but can you confirm if you can see my the first slide of my PowerPoint presentation?
show your first slide now.
Yeah. Can you see my first slide in the room?
And we
On the virtual side, I can see it.
Okay, I think I used the screen sharing button on the tool, but I can retry again. Just a moment. I am sharing my screen number 1. Can you see anything?
Yeah, it works.
Okay then.
Not for us, but we have to wait a little bit.
Okay, sure. But so am I? Can you see my screen
Pardon?
from the audience or in the room?
We haven't the PowerPoint now in the
Okay.
rooms. We haven't your slide.
All right.
But sometimes we need to wait. There is
virtually it works well.
It works okay for you? Okay.
Yeah.
But not for us. Oui. Oui, c'est ça. Frédéric Grand, c'est mon binôme chairman à distance.
Il n'a pas sa caméra. Je sais pas si c'est normal.
Non, mais il a peut-être pas besoin de caméra. Frédéric, tu as une caméra?
Ah oui, je peux la mettre hein, si vous voulez.
Voilà, essaye de la mettre pour qu'on voit si on te voit.
Ouais.
Ok.
C'est bon.
Alors donc on te voit. Donc quand tu prends la parole, bon, ce qu'on essaye de faire, c'est qu'on te voit quand tu auras la parole aussi.
Ouais, ok, ça marche.
Voilà. On voit toujours pas le PowerPoint. We can't see your PowerPoint, your slide.
Okay, but I think I am sharing it already in my browser, and someone from the virtual audience already confirmed that it's visible.
Yeah, I think it's an issue in the room.
Okay. Sorry about that. Is there anything that I can do, or is it just something that can be done in the room?
I think that can only be done in the room because for me it works well.
Okay, I see.
Tu la vois toujours pas? Ouais, il mouline. Et là, quand tu vas faire aussi les deux écrans de la manip que tu as fait, peut-être pas le faire, non? C'est pour pas qu'on ait d'écho. Tu refais pas la manip de tout à l'heure?
Non, c'est que j'avais ouvert ça, donc le speaker, dans une nouvelle fenêtre.
D'accord.
Comme si je faisais, non pas ça, mais j'avais fait genre ça.
Ok.
Et je l'avais du coup, je l'avais fait ici.
Ouais. Ok. Ouais, donc bon, fais-le pas là.
Non.
Donc là, normalement, moi, je dois le voir sur l'écran. Ouais, it's okay. So, Valtteri, it's okay for us.
Okay.
Everything looks perfect. So we wait maybe you are planned for 45, so maybe in 5 minutes it's okay for you. Okay?
Yep, sure.
3-4
Yeah,
minutes.
that's okay.
3-4 minutes.
Yep, sure.
We hope
I'm
people
ready.
will come back in the room and.
Yep, very good.
Okay, thank you.
Thank you.
Okay, Valtteri, you're okay?
I'm okay, thank you.
Okay, so the room is yours. You can begin. Everything is registered, and you have 20 minutes for presentation and questions after. So let's go.
Yep, okay, thank you. So good afternoon, everyone there in the room and also attending virtually. Thank you for joining my presentation. My name is Valtteri Broterus. I work for WSP Finland, but actually today I am representing the alliance as a whole. I mean the Kalastamo Pasila Alliance project. And I'm going to tell you about the collaboration in these very exceptional circumstances in our Kalastamo Pasila Light Trail Alliance project. And as you can see, unfortunately, I wasn't able to travel in France, but I really hope that I will be able to meet all of you next year in person. But yeah, let's get going then. First of all, I would like to introduce myself from professional perspective. So I am an alumni from University of Oulu in northern Finland, where I did my Master of Science degree in engineering and environmental engineering as my major subject. And in my early years of my career, I worked as a geotechnical design engineer. So I have that background before my current role. And for the last around 5 years, I have worked as the BIM coordinator in several infrastructure projects in WSP Finland. And I wanted to highlight some of my biggest project during my WSP career so far. So I started with the Crown Bridges Light Trail project in the city of Helsinki. And for the last couple of years, I have worked with the Vantaa Light Trail located next to Helsinki in the city of Vantaa. And finally, this Kalasatama Pasila Light Trail Alliance project, also located in Helsinki. So it's been quite a lot light trail projects during the last few years on my desk. But then something about the content of my presentation today about the alliance in collaboration in these exceptional circumstances. I will start with telling you something about the city of Helsinki, which aims to be a very functional light rail network city. And then I'm going to continue about some general overview about the project, this Kalastamo Pasila light rail project. And then I'm going to dive deeper into InfraBIM and BIM details about or in this project. And finally, I will share you some experiences how we have faced these exceptional circumstances in our alliance collaboration. So to start with, here's a map view of the city of Helsinki, and you can see some white lines in this picture, and they are describing the current the tram network in the city of Helsinki. And actually, the tram traffic in Helsinki started in 1891, so it's been 130 years already. And currently, we have 10 separate lines in the tram network in Helsinki. And in total, the length of the network is around 40 kilometers in Helsinki. And when we jump into the future, maybe 10 years from now, Helsinki is planning to expand the current tram network in looking like this. So all the green lines are not existing yet, but they are planned to be constructed during this current decade. So it's pretty obvious that the network and the connections in the tram network in Helsinki is going to be much better in 10 years. Then some details about the project in the key figures. So first of all, it's going to be around 5 kilometers of new way track in the Kalastamo Pasila Light Rail Alliance, which we are going to construct. And there will be around 10 new tram stops within the new tram line. And the average speed in the new tram line will be around 20 kilometers per hour. And when we compare it to the current Helsinki tram network, it's around 30% faster than the current network. And the reason for that is that because most of the current tram network in Helsinki is located in the city center, where they are they have joint lanes with the car traffic, so they can't drive that fast. But hopefully we are able to increase the average speed in Kalastamo Pasila light rail in the future. And the average distance between the stops will be around half a kilometer. And the budget for the actual light rail will be around 80 million euros. But when we add there the actual or all the connecting street structures and other street works, there will be another 120 million euros cost for the project. And this latter number includes all the municipal infrastructure, bike lanes and pedestrian lanes, and the green infrastructure in the street network. And the one thing which is exceptional here is that for the first time in Finland, this project will be or has been and will be implemented by two different project alliances. The bigger project alliance here is called Sörkan Spora, which consists of companies called Destia, Sweco Finland, and WSP Finland. And then we have a so-called sister alliance project called Jacquart, and this project alliance consists of companies called GRK and AFRY Finland. And then the major goal of this project is that we are aiming to connect two major transport and working hubs in Helsinki, which are called Kalasatama region and Pasila railway station. And by the year of 2030, the region of Kalasatama will be a home for 30,000 residents, and it will has around 10,000 workplaces in the area. And one interesting detail about the tram line is that there will be, around 1.5 kilometers of the track will be built to a historic park scenery. And because of that, the sustainability is at the very core of the project, which means that the whole project will be CEQUAL certified, including the development and implementation phases in the project. And when we look at from the BIM perspective, we have set special emphasis on information and data management in the project. And practically that means that we have set up a real-time project, a virtual project dashboard for follow-up, and which will be and has been open for all the project employees 24/7. And in addition to that, we have developed some in-house tools for risk management, decision making, and scheduling. And then the BIM practices and the BIM experiences during this project, which we have done since May 2020. So the first challenge here was obviously that how do we smoothly compound all the design solutions over the organization barriers. I told you earlier that in this alliance project we have around 5 to 6 companies which all have their own design softwares, and somehow we need to combine all the design solutions so that we can design and construct a good light rail network. And the target was that we wanted to make sure that the daily working methods, which means practically the design softwares, etc., that they should be the same, that the alliance employees are already familiar with, that they would have the freedom of choice in their personal design softwares, as long as they can follow our agreements about the mutually agreed BIM file formats when they model their design solutions. And the best solution to meet these requirements was Trimble Connect, and we set up Trimble Connect as the joint alliance collaboration model platform. And as a consequence, each of the project members in Kalasatama Pasila Light Rail Alliance is able to work with their own design software in their own employer's IT or ICT environment, but still collaborate with all the alliance colleagues from the other companies, despite even though they are not working in the working with the same softwares. And then some other details about the modeling. So obviously we had to build up a BIM organization in the project to supervise and follow up that all the like the BIM requirements are followed during the project. So first of all, we have several BIM coordinators in all the member companies. So we have BIM coordinators on the design side, but we also have the BIM coordinators on the site, on the contractor side. And then when we go deeper into practical work, we have like BIM ambassadors or correspondents in each technical discipline who are responsible in communications between the BIM coordination and their own disciplines modeling or the design team. And then there's a very important role for the site automation operator, aka the contractor. So basically the site automation operator uses the BIM models which are produced on the design engineers table. And after all, everyone in the project has some kind of role in the BIM organization, and to support this idea, we have given an access to Civil Point Map Extension BIM platform so that everybody would be able to view the design solutions very easily without any software installations. And then the final slide on the BIM practices in the project. So we have set up a certain like a roadmap how we produce the BIM models from the design engineers table to the construction site. And the steps start with the basic principle that each discipline and design engineer is responsible to model or their design solutions, and the collaboration during the design phase is being done all the time, utilizing the Trimble Connect and the BIM team meetings. And basically, in the daily job of a design engineer, they are uploading the BIM models from their own design solutions to Trimble Connect, and vice versa. They are able to utilize their colleagues' BIM models by synchronizing them from Trimble Connect in their own design software's database. And to make sure that we have a good quality of BIM models in the projects, we have set up a documented quality check process, which consists of 3 steps. And the first step is the design engineer self-check, where the design engineer does a certain checklist to make sure that the BIM models are technically valid. And then the next step is the BIM quality control of the BIM coordinator from the design side. And finally, the contractor's BIM coordinator makes their own quality control to make sure that all the BIM models are like valid for are working in the machine control computers. And we will create some sort of as-built models. We haven't actually decided in details that what kind of as-built models will we build in the end of the project. But there are some pilot projects on City of Helsinki where they have piloted the practices about the as-built model. So we will probably have some development sessions with the client that what kind of as-built models do they need in the end of the project. And as probably the Finnish members of the audience know, that the BIM utilization in maintenance phase is a little bit question mark at the moment. There's not that much experience that how the maintenance phase could utilize the BIM models produced in the construction, but there's a strong emphasis that we are trying to make good practices in the BIM models, so that the maintenance phase could utilize those models in the maintenance phase of this life cycle. And then finally, the last part of my presentation today is telling the experience that what kind of the collaboration has been in this alliance when we have had these exceptional circumstances. So first of all, as I mentioned previously, the project started practically in May 2020, which was pretty much the starting point of the COVID pandemic in Finland. So the initial idea before the pandemic hit in was to work in a big room environment, which would have collected all the client, design and construction colleagues in the same space. And we actually have the big room set up, but it's obviously pretty empty currently. But then all the pandemic restrictions in Finland were set up, so we were not able to work there like 100%, but there were like limitations of the number of people who could be there at the same time. And practically we transferred right away in distance working and virtual big room collaboration. And as we can imagine, the very first major challenge was that how do we learn to collaborate with these new colleagues from other companies without being in the same room? Because I think it's pretty obvious that when we don't know our alliance colleagues from the other companies very well, it's hard to collaborate with them, and it might be even hard to trust or create any trust between the members. But obviously, all the challenges has been made to solve them or to be solved. And the solution and the next step was that we were forced to start utilizing the digital collaboration platforms to replace the physical attendance in in the big room. So practically we have used very much the Miro boards, and then this tailored project management tool called Proma in the project. And then we have set up also the project intranet web page where we do all kind of communications inside the projects, and then very many other like digital collaboration platforms. And other difficulties have been obviously that when we have mostly been working from home, there hasn't been any spontaneous information sharing sessions or ad hoc meetings at the big room. And also other difficulties has been that we haven't been aware of what the other technical teams are doing, because we are working physically in different locations. But despite all these challenges, it's been an interesting and interesting journey, which continues until year 2024, when the traffic hopefully will start in this new light rail connection. And even though we have had these difficulties, the success has been that the big picture of the project is still in order. We already started the construction phase in the I would say that in the end of last year, and we have a solid plan how we can continue by working in these exceptional circumstances in order to make the things happen and construct the tram connection by year 2024. But so my name is Valtteri Proteros, and I work as the BIM coordinator in Kalastama Pasila Light Rail Alliance. And here we have the web page of the external web page of the Alliance project, and it's translated in English if you're interested in finding out more details about the project. But I think it's time to thank for your interest, and if there's any questions, I'm happy to answer to them. Thank you.
Well, thank you for presentation. Some questions in the room? It's okay? Questions? Okay.
Thank you, Valtteri. It was very nice presentation. In the beginning, there was two of us, me. My name is Tiit. I'm from Digital Construction Cluster of Estonia, and my side is Jüri from the Ministry of Communications and Economic Affairs. In Estonia, we are just in the beginning. We are looking for how to begin with this. Can you assume approximately how many projects in Finland are done in alliance contracts of all the projects? And the second one, what are your suggestions to Estonia, how we could take this step? Thank you.
Thank you. Very interesting and good questions. First was about the number of alliance projects in Finland. First of all, I would like to divide between like infrastructure alliance projects and then the building alliance projects. And I'm actually more aware of the infrastructure projects. And I would say that the total number within the last decade would be maybe somewhere around, I would say 10 to 15 alliance projects, depending on how you define actually alliance projects, because some smaller projects might have some features of an alliance project, but then it's hard to make a difference. Is it actually an alliance project or a traditional project with some new features? But as a whole, I think that the building industry in Finland is very satisfied with the good findings in alliance experiences. There have been many great experiences in the alliances, because the schedule has been actually they have been able to finish the sites before schedule, and the budget has been like there has been the actual costs has been under the budget, and it's been very successful method to conduct the project. So I'm very strongly recommending to all the infrastructure owners to consider this kind of project form. And the second question was about how to make the step towards the alliance project in Estonia. I know that Estonia in general as a society is very agile in digital perspective. You have these digital citizenship things and things like that. So I believe that you have a very good starting point because you already trust in this kind of like collaboration and digital agility. So I think it's always when new methods and project forms are started, it requires the leap of faith that you just have to make the first step and trust that it goes well. But I think that the mutual trust between all the parties, the client, the contractor, and the designer must be achieved in order to make a good alliance project.
Okay, thank you. Another one? Question? Frederick? Umbrella, do you have something?
No questions on the chat.
No questions on the chat. So maybe one comment or question. So in your slides, you say some words on the pandemic situation, and the necessity to work at home. So, and you said it's good or not good to learn to work together on platforms, and when we are not in the same room. So in the same room, numerical room, but not the same room to speak very fluently or say something. What is your opinion? Do you think the pandemic is an acceleration? And what will be the situation in maybe in 6 months, 1 year or 2 years? So acceleration or normal things?
Well, if we imagine that someday we will get rid of this pandemic situation, I think that we will return on some scale back to normal collaboration, being physically in the same place. But I think that during this pandemic we have learned many good working methods, so that we are able to collect the best possible teams to work in alliances and work in same projects despite where they are located. So I think that the good thing that in the future we can collect the best teams in the projects who might be geographically located in very long distances. So I think that we're getting back more to the previous normal, working mainly physically in the same space. But naturally, we're able now to consider also the distance working.
Okay. Okay. No questions? No more? So it's time to have a drink and to stop the session.